All right, should we get started? Ah, hopefully you had a chance to get your breath over break and you're ready. We got 2 weeks left, and 2 weeks from today we'll be done with this class. So that's very. If you look at our calendar here, for November or December, it's the first. We have 2 weeks of classes, and then final exam week. But in final exam week, this class's final exam is the first day, that Monday. So you'll take the final exam on Monday, the 15th. And then we'll also show our projects, and we show that off at the CIS showcase, which is at 4 p.m. on Monday, also here. So by uh, by the 15th, you'll be done, completely done with this class there. So we're going to be a busy 2 weeks, but we'll have that. We will have a fair amount of time in class to try to give you some opportunities to do some of this work there. So what do we have to do? So I've opened up the final project, final exam and final projects stuff here. The exam will do some review and some study with that. And again, if you remember for the first one, it's a fair amount of terms and some basic block programming questions. It'll be very similar to that midterm idea. So we'll talk about that more next week when we get to that review. So that'll be the final exam. We will work on our final project in mobile CSP. This is called Create Task 2. Here, you'll just create an app. We're going to do it in partner, so you'll be assigned a partner to work with on your final project. It'll be due in exactly 2 weeks from today there. So we will try to assign partners in class this coming Wednesday. So our next class where you do that. So if there's someone you want to partner with, I will take recommendations or suggestions in 2 weeks. If you don't have anyone you want to partner with, I will assign you a partner to work with, and together you'll work on class. Because you'll be partnered up, we'll have a number of times in class where you can work together on this stuff. So it's starting with Wednesday. So Wednesday, come and think of who you might want to be partnered up with here. So that's the two big things coming up, is the final exam and the final project, both due in 2 weeks. We're in the next 2 weeks, we'll also work through Unit 7 and do our reflections and an assignment in Unit 7 here. Eventually, some people have been asked about extra credit, so next week I'll release these extra credit opportunities and some opportunities for extra credit if you're interested. But let's jump into Unit 7. This is our last mobile CSP stuff, and hopefully you're kind of used to what this is. We'll spend 2 weeks on it. There'll be reflections due, so you might want to make a copy of the reflections document and do this. We'll start working through these projects here. I like this unit because we get into data, and in particular, we get into AI and machine learning, and that is my area of expertise. My favorite class to teach, one of them is our machine learning class there. So we'll go over some of the mobile CSP, and I'll bring in a couple topics from our advanced machine learning class to give you a preview of that class and some stuff we could cover there for this. I'm not sure. We'll have to see on this how many of this, if we'll hit this stuff. In particular, the clicker app, I'm not sure if we're going to get to all of that stuff. So we'll try to work through this in the next 2 weeks, and we'll see. I think we'll have time for it. Oh, and we also have one more project we'll be doing this week, and that'll be our data analysis project, where we'll start talking about that today, and that'll be due this Sunday. So again, Usually on a 2 week cycle, you don't have anything due until the end of the 2 weeks, but the end of the semester is the end of 2 weeks. So this one assignment we're going to fit in early on. It'll be due this Sunday for this. So let's jump in right away and get started on it. We're going to go to mobile CSP 7.2 and talk about that. So this is getting us introduced to data and what we call big data and what that is here. We'll go through this. I'll just warn you, and again, you might be used to this at this point. We'll be doing lots of stuff, but if you scroll down, you're going to be responsible for these reflections, the reflection documents. And in particular, all those are tied to this big data activity where you want to pick some big data set and explore that. And we'll give you time to do that. But if you want to start looking ahead, that's what you're going to be doing and reflecting on. So I'll build towards that here. Just so as we get started, we'll talk about some sizes of stuff. Let's talk about some terms. So just so we're clear on these terms, kilobyte is 1,000 bytes, megabytes is 1,000,000, gigabytes is 1 billion, and terabyte is 1 trillion bytes. So each one of those is a jump up, and you're probably familiar. I mean, certainly I think you're familiar with kilobytes, megabytes, gigabytes, and terabytes there. Just so you know, when we go above that, we go to petabytes and exabytes on zettabytes. So those are some of the bigger ones. And each one of them, again, we're looking at 1,000 more times what we have there. It's interesting to look at storage stuff. I have hard drives in my that are 10 years old in my office that are 1 gigabyte drives, hard drives, and they're big. I should have brought one down. They're big hard drives. And just last week, I bought a new hard drive that is 5 terabytes and it's smaller. So it's smaller and 5,000 times more storage than the old ones. And that's what we've seen. We've seen certainly computers increase, but we've seen storage increase. We can store a lot more information out there for this. And we generate a lot of information here. This is just a visual of the storage out there. Once I get back to data, like I was just helping someone clear out a computer from the 1990s, and it didn't have that much stuff on it because back then we didn't digitize. We didn't have that. I mean, it had documents and it had our accounting spreadsheets on it, but she didn't take any photos. We didn't have digital photos. We didn't have digital videos back then. We didn't, she ran a business and so she has a whole bunch of paper, right? She had a big file cabinet full of paper records there. And not very much, only like her monthly totals, which she would run. I think she was running Quick and some financial software to run her local business. And only the like big stuff was things that she had to manually enter everything into there. And so she didn't, enter everything in there, maybe checks she wrote on things like that, but not everything she bought or anything like that. Because no one would enter all that information. But today we generate so much data and so much of it is digital there. So, I mean, you can track, like think of everything you bought in the last year. Is there an electronic trace of almost everything you bought? You either use a credit card or you probably use the website for that, or a store and they scanned it electronically. So there's probably multiple ways of everything you bought. How many photos or videos did you take, or how many photos or videos did you watch this past year? I just got a new laptop, so I just copied all my photos from my phone onto my laptop, so I'd have them backed up there. And I don't take that many pictures, but so it was only like 1,000 or so photos. But again, that was still 1,000 photos there. So how many? So this just kind of shows you this whole big data stuff. Tweets, how many million tweets are generated every day? How much data is uploaded to Facebook regularly a year? So again, this is petabytes there. Messages that are sent. So just how much data is used for your car and tracking there. It's kind of, do you do any of the end of the year sort of stuff? So the track, so like, Spotify has their end of the year playlist or whatever, summary of you if you listen to Spotify music. But also, on my Google Maps, it'll show me everywhere I've been this year and all the traveling I've done, or and what routes are really popular, because all that map data is there too with me. So again, my daughter is a younger generation. She is turning away from her Apple Watch and back to a analog watch, and she says analog is coming back in. So I'm interested to see. I still have my Fitbit, and I like my Fitbit. But again, all that data is dumped into electronic form for that. So there's so much data out there, and it's so much easy to access there. I'm going to play a couple of these videos. And again, so you can watch these. And again, if you're interested while we're listening to these videos, you're free to go down here to this activity and pick a data set. The first two links I don't think are that great. The Korg GIS data set, clicking in and look at the visualizations there are pretty good. And then the 3 New York Times ones are good. There's actually more New York Times ones in the reflections. If you open that up, I think I put those there. Right. I put a link to a newer article from the New York Times that just highlights some of their data sets that are free to students and available. So you can look through, I think that link is really good. That's right away in your reflections, updated one. Okay, so let me play these videos. Turn my volume at here.
In recent years, our technology has allowed us to store and process mass quantities of data. Visualizing that data will allow us to see complex systems function and see patterns and movement in ways that were previously impossible. Almost everything is measurable and quantifiable. So when I look at data, what's exciting to me is kind of recontextualizing that data and taking it and putting it back into a form that we can perceive, understand, talk about, think about. This is the data for airplane traffic over North America for a 24-hour period. When it's visualized, you see everything starts to fade to black as everyone goes to sleep. But then on the West Coast, planes start moving across on red-eye flights to the east. You see everyone waking up on the East Coast, followed by European flights to the upper right-hand corner. I think it's one thing to say that there's 140,000 planes being monitored by the federal government at any time. And it's another thing to see that system as it ebbs and flows and try to be afloat.
Anyone get delayed in any of those storms on planes? Anyone fly anywhere? Yeah, where were you delayed at?
I was from Duluth to Chicago.
Ah, yeah. My daughter was doing the opposite, and I had another student going Minneapolis. No, yeah, Minneapolis to Duluth, and both of them were on canceled flights. So yeah, you just see this, and yeah, that snowstorm knocked off a lot. They said 10,000, no, 1,000 flights out of Chicago were canceled in 2 days. So.
Text messages being sent in the city of Amsterdam on December 31st. You're seeing the daily flow of text messages from different parts of the city until we approach midnight, where everyone says,
it takes people or programs or algorithms to connect it all together to make sense of it. Yeah, and that's what's important. We have every single action that we do in this world is triggering off some amount of data. And most of that data is meaningless until someone adds some interpretation of it, someone adds a narrative around it.
Opportunity to sort of think of data as stranded numbers, but they're tethered to everything. And if we follow those tethers in the right way, we can find the real world objects and the real world stories that were there. So a lot of the work is that kind of work. It's the almost investigative work of trying to follow that trail from the data to what actually happened.
You've probably seen this triangle before. How we want to try to go from data to information, information to knowledge, knowledge to wisdom, or something like that. There. So we have lots of data there, and a lot of companies spend a lot of money trying to turn that data into useful information that they can then act upon, or some knowledge there. Companies often are not necessarily trying to strive for wisdom, but I think as individuals, that's what we're often looking for from the data is, what trends, what topics, what do we see from this sort of data there, and how far up this ladder can we go with that? So, and world. I'm gonna play I'm not gonna play all these. I really like. So again, they're talking about all these videos. I really like this video because it talks about collecting data on a kind of smaller scale and in an area you wouldn't necessarily think of. How does a young child acquire language there? And it's interesting once we get this, and especially now that we're training a lot of LLMs to acquire language almost in a similar method. So.
One way to think about big data and all of the computational tools that we wrap around that big data to let us discover patterns that are in the data. We point all of that machinery at ourselves.
At MIT, Deb Roy and his colleagues wanted to see if they could understand how children acquire language.
And we realized that no one really knew for a simple reason.
After he and his wife Pao brought their newborn son home from the hospital, they did what every normal parent would do. Mount a camera in the ceiling at each room in their home and record every moment of their lives for 2 years. I mean, 200 gigabytes of data recorded every day.
Oh, no, we ended up transcribing somewhere between 8 and 9 million words speed. And as soon as we had that, we could go and identify the exact moment where my son first said a new word. We started calling them verbs. We took this idea of a word for it. We started thinking about, why don't we trace back the time? What is the gestation period for that word? One example of this was one. So we looked at every time my son heard the word water, what was happening where in the house were they, how were they moving about, and using that visual information to capture something about the context within which the words are used. We call them wordscapes. Then we could ask the question, how does the wordscape associated with the word predict when my son will actually start using that word?
What they learned from watching Deb's son was that the texture of the wordscapes had predictive power. If most of the previous research had indicated that the way language was learned was through repetition, then this analysis of the data showed that it wasn't actually repetition that generated learning, but context. Words with more distinct wordscapes, that is, words heard in many varied locations, would be learned first.
Not only is that true, but the wordscapes are far more predictive of when a word will be learned than the frequency, the number of times it's actually heard. It's like we're building a new kind of instrument, like we're building a microscope. And we're able to examine something that is around us, but it has structure and patterns and beauty that are visible without the right instruments. And all of this data is opening up to our ability to perceive things around us.
So I thought that was a good example of where, if you're given more data and then trying to get information or knowledge from that data, and how it works, with that, idea. It's also interesting because, I think it's related a lot to new AI stuff. The current models, large language models you have just been using language and not really any real world, information. And so one of their problems is they don't have a lot of context. But current research and current, work on a lot of AI models is now working more like with robotics or 3D, attaining or training languages in more of a 3D environment, for this, with what we call maybe like a world model or something like that, because of some, research like this that shows that, it's actually more useful to see how language or acquire language in context for that. So, I'm going to skip over this, smallest heartbeat. I really think that's a neat video, but I want to, you can watch it on your own, there. I want to get to some of this other data, and show you one of Joy's talks on bias in big data, here. I think I'm going to do this first one. We have two, talks by Joy, about bias in face recognition data. And I think I'm going to do this first one.
My research how computers detect, recognize, and classify people's faces. In my TED featured talk, I spoke about my experience with the coded gaze, my term for algorithmic bias. The system I was using worked well on my lighter skinned friend's face, but when it came to detecting my face, it didn't do so well until I put on a white mask. After my talk was posted, I tested my speaker image profile across different facial analysis demos. Two of the demos didn't detect my face. The other two, well, they misgendered me. The demos didn't even distinguish between gender identity and biological sex. They just provided two labels, male and female. Now I wanted to see if these results were just because of my unique facial features, or if this was something that was more of a pattern across other faces too. So I began a project that became my MIT, Gender Shade, or the long title, Gender Shade's Intersectional Phenotypic and Demographic Evaluation of Face Data Sets and Gender Classifiers, or just Gender Shade. I wanted to see how well different gender classification systems worked across different people's faces, and if the results changed based on somebody's gender or their skin type. I created a data set of over 1,000 images of parliament members ranked among the top 10 in the world based on their representation of women in power. To get at a range of skin types, I chose 3 African countries and 3 European countries, so I could see how the system performed on lighter skin and darker skin. Then I chose 3 companies to evaluate: IBM, Microsoft, and Face++, which has access to one of the largest data sets of Chinese faces. So now with the data set and the companies, I decided to run a test. The companies appear to have relatively high accuracy overall. Microsoft performed best, achieving 94% accuracy on the whole data set. All companies performed better on males than females, and all companies also performed better on lighter subjects than on darker subjects. When we analyzed the results by 4 subgroups, we saw that all companies performed worse on darker female.
So let's just look at this data. So that again, what this is looking at accuracy of, let me back up just a sec so she just before she has this highlighted. She's looking at these 3 vendors and how accurate they are for darker males, darker females, lighter males, and lighter females. And let's just look at IBM here. Lighter males, 99.7. Lighter females, 92.9. Darker males, 88. And darker females, 65%. That's what IBM was at with that. Now, and again, this has been pointed out and stuff. One of the questions you're going to have to answer, or that's in here, is this question in the self-check, is that based on Joy's research, I've been retrained its system using more diverse set. So this is IBM. How would you interpret these results? So this is IBM's retrained model. Their lighter males are still 99.8. Light females are 100. Dark males are 98, and darker females are at 96.5. So still lower than the other ones. But again, in this video, the new model is 96, and compare that to 65%. So they certainly made an improvement from that old model to this model there. So it's interesting how this research made these companies go back and retrain their face recognition models for this. So, okay, let's go on.
IBM and Microsoft performed best on lighter males, and Face++ performed best on darker males compared to the others. IBM had the largest gap in accuracy, with a difference of 34% in error rates between lighter males and darker females. I was surprised to see multiple commercial products failing on over 1 in 3 women of color. In fact, as we tested women with darker and darker skin, the chances of being correctly gendered came close to a coin toss. While more research is needed to explore the specific reasons for the accuracy differences, one general issue is the lack of diversity in training images and benchmark data sets. Failure to separate accuracy results across traits like gender and skin type also makes it harder to identify differences. Companies should do better with commercially sold products, especially since the machine learning techniques that have made gender classification possible are applied to other domains of computer vision, like facial recognition, and other areas of artificial intelligence, like predictive analytics. Predictive systems can help determine who is hired, granted a loan, or what information a particular individual seeks. These data-centric technologies are vulnerable to bias and abuse. As a result, we must demand more transparency and more accountability. We have entered the age of automation, overconfident yet underprepared. If we fail to make ethical and inclusive artificial intelligence, we risk losing gains made in civil rights and gender equity under the guise of machine neutrality. The coded gains reflected in the Gender Case project must be fixed.
So again, her work was, much of it was published around 2017, and companies have taken steps to address that. There's still issues with this, with bias in this stuff. A lot of the obvious ones, I believe, I feel have been addressed, but again, there's a lot of subtle bias that is still in our data sets for this. One thing that you will see and may run into is just resume evaluation. Most companies, a lot of companies use a computer to screen resumes. If they get 1,000 resumes, they'll screen it down to maybe 50 that they'll want a human to look at for that. And so they've often trained AI systems to go through, sort through, given a job description and requirements, sort through 1,000 resumes and only pick those that match. Companies have run into problems with training those systems and removing bias from those systems. There's significant research that shows that there's this natural bias against certain individuals. For example, if you change your name on your, if you submit 2 resumes and one has a female sounding name, one has a male sounding name, the male sounding name tends to get a lot more callbacks and actions than the female sounding name. And same with different backgrounds or ethnicities for those naming them. A lot of companies now are stripping the names from them, but our computer systems now can often tell your gender and information by things that are in your resume rather than more than just your name there. So it's a challenge, and companies are still working on those sort of subtle things. So if you are given someone's resume and you don't know their name, what can you tell from them based on just what's listed in their resume? So, okay. Let's jump into this activity here. So we want to pick one of these data sets, find some new facts that you can learn from the data set, write a question and state it as an hypothesis for this, and then try to explain, if you have a visualization, what that does. So I'm going to scroll up here to these data sets. The Wikipedia article mainly just talks about big data, and it's a nice read, but and they have some links to big data sets, but I don't think it's the greatest. Reddit is okay. Data is Beautiful is a nice subreddit if you're interested here. This, you can select like the top responses from like the last month or something like that here, which is somewhat interesting. But I mean, it is Reddit. So like, I typically like to look at the top responses for the last year, and the top response from this year is a toilet data set. That's Reddit for you. So, but again, you can find some good Reddit, and again, it's creative, so that's sometimes fun. So, the core GIS data sets, if you go there, again, you can process this with these different languages, but the visualizer is where you want to go. You want to go to visualizer and you want to select one of these things here. So what do we want to do? Maybe we'll do Broadway plays. I don't know if I want to do Broadway plays. Let's do food access. The interface for this isn't the greatest in some ways. So again, they should describe this data set up here. So they're talking about US Department of Agriculture, looking at in the US, how close are the nearest supermarkets or grocery stores where you can get affordable food and healthy food here. So maybe not a dollar store, but an actual supermarket which would have grocery or, like fruit and veggies and stuff like that for the access. So you can select the different types of graph, and usually there's some way to change this. So like this is just looking at the population of different places here. And we can look at different charts. And sometimes, depending on when you make changes, you'll show different things. So now I change it to a bar chart. Also, I can select which states to include here. So now I can say, oh, I want to make sure I put Minnesota in the list, and maybe I want to put Wisconsin in this list and show it. And then maybe some of the bigger states, well, what does California look like? And again, when you add something like California, it's so much bigger than everyone else often that it'll show up. Or same with, I think, like New York would be similar sort of stuff. So some of these states are just so much larger than everyone else. So again, you can decide how you want to visualize this, if you want to include those or not in this. So again, and again, if I switch to a different plot, I don't have that. So sometimes you'll see different things from that. And then you can plot. So this is just showing population, but if we're looking at food insecurity, we're more interested in like access, number of children that are 10 miles away from a supermarket, for example, for this. And when I look at that, the state with the most children that don't have access to good food is Minnesota. And that kind of makes sense because we're very rural here, and there's there's not, because of the cold weather and stuff, there's not as easy access to vegetables and stuff like that for this. You can also then look at this, well, what if we look at it by income level also? So not just low access, but we look at income levels, and if we add that, we'll see different results. And again, you can add different states. I'm going to add Alabama in here because I know Alabama has a really significant problem with this related to both access to food, especially with the income level. So if you're low income, you have much more likely to have this. So again, you want to pick some data set like this. And again, you can do one of these correlates. The New York Times ones are just kind of ways of like visualizations that are kind of set like the student debt one is kind of an interactive visualization, but I think it's a little easier to see here. So like I can select private versus public. Here's public institutions, here's private schools. I can see those. Or I can do all colleges and see the differences there. So again, you can kind of do some changing of these things, these visualizations here. I'll just warn you, some of these are older. So like this data only goes through 2010. So again, that's 15 years old. That's why I linked in this. This is a 2025 article with newer visualizations from the New York Times, similar to this. These aren't all in the last year, but again, a lot of these are some newer ones that you can look at. So you want to pick one of these, and for your reflections, choose some data set here and describe what the data set is and what information it has. Sometimes you have to kind of look at this and see, like what are they looking at here? This is, like this student debt one, it looks like they're looking at everyone's students' debt amount there, and they have something about each of the students, a little bit about each of the students, it looks like, or at least what college they're from here. But there's don't have pictures of student debt. There's no videos in this. Similar to this one, this is our food access visualizer. again, if I look through this, it looks like and looks at the different values. It looked like we classify people as low income or not, child, seniors, or just all people, and then how far they are. So there's some mapping distance here. So they must know where these people are, or at least how far they are from it. So sometimes I can actually go to this data set and look at the data set itself and download or view this data set for this. So sometimes that you can look at it. But a lot of this data set is just going to be text and some, and numbers for this. Maybe not a lot of sounds or stuff. And then again, list 3 facts, explore the data set, try to do some filtering, try to do some different graphing, visualization, whatever, and list some new facts that you want there. And then state a hypothesis for this. So my hypothesis, I'm going to go back to the food data set. Where did I put that? I think I may have closed that. Oh yeah, I went. Okay. My maybe prediction is that, hypothesis maybe what are colder states more likely to have problems than warmer states. So I'm going to select some just people 10 miles from a grocery store. I know if I do a bar chart, if I do a histogram. Yeah, if I do a bar chart, I can select different states. And so I'm going to pick some of the most northern states here and some of the most southern states for this stuff. So I'm going to get rid of some of these middle country states and just pick up, what are my northern states, the Maines, the Vermonts here, North Dakota, and maybe Washington State here, and Minnesota, of course. And I'm going to look at some of the southern states. So I've got Texas. I want to do Florida. I want to do California, maybe New Mexico. And then I want to, and maybe let's do Arizona too. And my idea was that states that were colder would have more problems. But when I drop in these, again, this is just a sample, that doesn't seem to be the case. Arizona is way much higher. So maybe if I even remove that, New Mexico and California are 2 of the top states. And then we have a bunch, Washington, North Dakota, Minnesota. But Florida, Alabama are, so I don't see a trend based on North and South states. So what would be my hypothesis here? So my hypothesis is that maybe I'd say if a state is in a northern climate or a winter climate, it'll be more challenging to provide fresh groceries and vegetables, fresh fruits and vegetables for that. And so I should see higher food insecurity in these northern states. And then I can test that out and say, I don't see that trend for that. So you can identify privacy data with this sort of stuff. One of the questions is can you download this data and see? So, I mean, certainly like with the student debt one, we don't want to be able to look at each of your student debts there. And so I shouldn't be able to look at this. I can certainly go to a school like Scholastica. Is Scholastica in here? Yeah, here, go to Scholastica and look at it and see information about Scholastica. But I shouldn't be able to see information about any of your specific college, debt, loans or what your loan rate is at. So that's, I mean, for that. And so I want to make sure that this data is general enough so that I can't pick out any particular person or something like that. And again, is there a visualization that you found useful for that? Okay. So that was this. I'm going to go on to 7.3 here and talk about visualizing data a little bit more. So 7.3 looks at some common visualization methods here. Well, interesting visualizations. Some of the most, I don't know, dynamic or interesting ones often are these ones that show moving data. So this tries to show movement of what is often referred, population stuff here, and how the baby boomers, what the baby boomer generation is, and how it's moving through our system for this. Sometimes these visualizations that are actually moving they're kind of interesting, but again, they're sometimes hard to stop and see what's actually going on, especially if you don't have control over them and where this data is with like a slider or something like this. So there's a lot of interesting misleading graphs out there. This video talks a lot about those. I'm gonna try to jump.
A toothpaste brand claims their product will destroy more plaque than any product ever made. A politician tells you their plan will create the most jobs. We're so used to hearing these kinds of exaggerations in advertising and politics that we might not even bat an eye. But what about when the claim is accompanied by a graph? After all, a graph isn't an opinion. It represents cold, hard numbers, and who can argue with those? Yet, as it turns out, there are plenty of ways graphs can mislead and outright manipulate. Here are some things to look out for. In this 1992 ad, Chevy claimed to make the most reliable trucks in America using this graph. Not only does it show that 98% of all Chevy trucks sold in the last 10 years are still on the road, but it looks like they're twice as dependable as Toyota trucks. That is, until you take a closer look at the numbers on the left and see that the figure for Toyota is about 96.5%. The scale only goes between 95 and 100%. If it went from 0 to 100, it would look like this. This is one of the most common ways graphs misrepresent data, by distorting the scale. Zooming in on a small portion of the y-axis exaggerates a barely detectable difference between the things being compared. And it's especially misleading with bar graphs, since we assume the difference in the size of the bars is proportional to the values. But the scale can also be distorted along the x-axis, usually in line graphs showing something changing over time. This chart showing the rise in American unemployment from 2008 to 2010 manipulates the x-axis in two ways. First of all, the scale is inconsistent, compressing the 15th month span after March 2009 to look shorter than the preceding 6 months. Using more consistent data points gives a different picture, with job losses tapering off by the end of 2009. And if you wonder why they were increasing in the first place, the timeline starts immediately after the US's biggest financial collapse since the Great Depression. These techniques are known as cherry picking. A time range can be carefully chosen to exclude the impact of a major event right outside it. And picking specific data points can hide important changes in between. Even when there's nothing wrong with the graph itself, leaving out relevant data can give a misleading impression. This chart of how many people watch the Super Bowl each year makes it look like the event's popularity is exploding. But it's not accounting for population growth. The ratings have actually held steady because while the number of football fans has increased, their share of overall viewership has not. Finally, a graph can't tell you much if you don't know the full significance of what's being presented. Both of the following graphs use the same ocean temperature data from the National Centers for Environmental Information. So why do they seem to give opposite impressions? The first graph plots the average annual ocean temperature from 1880 to 2016, making the change look insignificant. But in fact, a rise of even half a degree Celsius can cause massive ecological disruption. This is why the second graph, which shows the average temperature variation each year, is far more significant. When they're used well, graphs can help us intuitively grasp complex data. But as visual software has enabled more usage.
Okay, so that just talks about one. And again, one of the things we train you to do in data analytics is to help visualize data. And often we are trying to make a point with this visualization, and we're trying to make a certain point. And so the question is that when, how much should you be cherry picking your data, or, picking out which visualization shows the, often there's some opinion, some point you're trying to make make with the data. And so how much of that do you actually include there? The other thing is this whole correlation versus causation. If you're not familiar with that, you should certainly do a research. Otherwise, you're going to think that by avoiding ice cream, you're going to avoid shark attacks here. So let's go down and do this Google Sheet activity. See, I think we have enough time to get a good start on this. So go down to activity 2 here. We're going to bring up this butterfly data set here. Make a copy of it. And I think these are butterflies from Costa Rica, if I remember correctly. We'll map it eventually. So there are different species here. And again, we're opening this up into a Google Sheet, a spreadsheet here. So you can scroll through the data. Each butterfly is on its own row here for this. We know what plant it was found on, the plant family, what year was collected, the elevation it was collected at, the wingspan of the butterfly, its ecosystem, and then latitude and longitude. We'll use this for plotting it on a map eventually. So what can you learn? I mean, this data, it's just raw data here. So let's do some work on it. And again, what you might want to be looking at is your reflection, write a spreadsheet formula that calculates the average elevation of the data in your spreadsheet. So again, in this data here, we can do calculations for this. So for example, if we want to calculate something, we can click like it, and generally you want to do this top. If I want to sum up all the rows, I'm gonna hit view, and I'm gonna freeze the top row. So then I can scroll through the data and it'll still be there. Okay, so I'm going to do the wingspan. And let's say I want to add up all the wingspans. To do a calculation, I go to a formula, and I say I want to add up. I can't just say I want to add up these cells or sum these cells. I have to say equals, and that'll do a calculation. And then I can type in a formula. In fact, Google is suggesting I sum these up. And again, there are certain keywords or formulas I can use: max, average, min, sum, and stuff like that. And so rather than saying add, I want to say sum, and then I can select the range, and it's selecting, again, each cell has an address. Each column has a letter, each row has a number. So K2 is the first one, and going down to K88, which is the last one. So that will let me sum up all these values here. But if I didn't want to sum them up, if I wanted to, let's say, find the maximum, what was the highest elevation there, I think max is a formula, so I can just type in that one here for this. Or min, or if I want to do an average, I don't know if it's av or average. I think it is average here. And that will calculate the average of things. And again, it has lots of significant digits, so often we want to reduce this to just maybe 1 decimal point or something like that. Again, this isn't a spreadsheet class, so we're not going to go over it. If you take information systems course, the 3105 course, you do a lot more stuff. Is anyone in info systems right now doing spreadsheet stuff? No one? No. Okay, well, I think, especially if you're all in the business area, you'll probably take information systems and doing much more with spreadsheets. So, okay. Are there more male or female butterflies here? How do you want to do that? So how do we want to do a calculation like that? So again, we have, I need to change this. Okay, we have the sex of the butterflies. Some of them are empty. They're not known, but a lot of them are male or female there. And how do we want to do that? So you could just count them manually here, or put in a formula to count them here. You could sort them by that and do that, and then maybe do some calculations on this. But there are ways of setting this up and doing a graph with this here. We're going to insert a pivot table to do this, I think. So I'm going to go over here and do insert pivot table and I'm going to do it in a new sheet. And here's my sheet. Now over in the rows, I'm going to want the gender. So I'm going to click over here. I'm going to click on rows and add the gender. And then for the values here, I'm going to add, I'm just going to count something. I'm just going to count the species, I guess. It doesn't really matter what I count. I'm just going to count something. And I'm going to make sure that this is set to count and not like sum or something like that. Why doesn't that work? Yeah. Oh, I'm wondering if what my data was set at here. Oh, it's been,
in rows, you can put sex, and then in values, you also put sex, and then
oh, does it? Okay, let's go back.
oh,
Edit that table again. So rows, values. Okay, yep. Put the sex in that too. Okay, so that'll do this sort of stuff. And then you can do a graph. You can just look at that and do a screenshot of that, or you can do a graph. Now, sometimes like Excel will have a pivot graph you can do here, but here I should be able to just highlight this and insert a chart. And see, and again, once I get a chart here, I can customize, or I can set it up, and maybe not a pie chart, but a bar chart will show me that I have more females than males. So again, if you're in this data, inserting a pivot table will let you get to a lot of different access data here. So are there more males or females? Which ecological environment do these butterflies live in? And again, so maybe if I go back here and go to my pivot table, I want to look at in the rows, I wanted to look at the ecological environment, the primary eco here, and I'm just going to count. I'm just going to see if that, yeah. So there's just cloud forest or dry forest, and I can see there are more in one than the other. Now my graph isn't working quite right because I added the data. So I'm going to redraw my graph here with my new data. Highlight that data and insert a chart. So again, you can play with this data. It takes, when you're first, if you haven't done much work with spreadsheets and some of this stuff, it can be challenging to get it to work with there. Some things you can look at is you can sort the data. So under tools here, we can say sort the seats by a column or by a column like here. I can sort by a column and sometimes that helps. I can also do some filtering with this data. I can then, filter and just select one environment or one species or something like that and see how that goes. So you can turn on or off filters. But the one I find most useful is actually this pivot data, pivot table to insert a pivot data. I like to put it on its own sheet here, and then you can show, create these tables and you can decide what you want to do as far as rows and columns and things like that. And again, you can add, like, let's say if we wanted to see if the gender, if the sex was different, I could add the sex here and see the breakdown, males versus females in cloud, dry forest, or rainforest. Okay. So again, we want to do that. Let's see. I'm going to quickly show you the map sort of stuff and tie you into that area. Let's see if we can do the third activity with Google Maps. So we're going to go to My Maps. It should show your activity here. You probably don't have any maps. I like to use My Maps. I have a ton of maps here for different things that I have. But we're going to create a new map. So again, here I went to this My Maps. We're going to create a new map here. We're going to import some data from Google Drive. And we're going to grab our butterfly data, and that's this butterfly data set. So over here, I might want to just search for a butterfly. To get just that data. And then it'll ask you to choose the columns for your position place markers. And for that, you want to choose latitude and longitude, and it should automatically do that here. And then the title, I'm going to do the species. So if I look at this data, I'm going to do what species it is. So I'm going to do species here and then finish that up. And here it'll show Costa Rica for this, and it will show where the butterflies were captured around Costa Rica.
What was it called? Choose a column to title your mark.
I did species, so then if I go into here, I can see, it'll just tell me what the title is. Let me do another one here. Which species of butterfly it was at that location. So again, you should latitude and longitude species for this there. You can actually set this up so that you could change the color based on this. Uh, and I think we could change the color. I thought there was a way to. I'm going to change the color by species there. So I should be able to click there. It's a uniform style by species. And then it'll show me each species and that will be a different color on the map. So again, and you can do a screenshot, remember, Windows Shift Fs will let you do a screenshot. You can copy that and paste it into your reflection stuff. I know I went over that quickly, so feel free if you still need help, call me over. I can help you see how that goes. See if you can get. Our goal is to get done with 7.3 today. Okay.